In this topic, we've been talking about momentum. We learned that momentum is a conserved quantity. Conservation of momentum makes it very easy to study collisions. The amount of momentum in a closed system before a collision is equal to the amount of momentum in the system after the collision. There are actually two specific types of collisions that we need to talk about in class. In this video, we will look at examples that we can discuss. I have two rubber balls. Observe their behavior when I drop them. You didn't expect that, did you? Let's watch again. Why does one bounce and the other one not bounce? The rubber balls are the same size. They have the same mass. They are even made of the same chemical. What is different? Here's a plate of spaghetti. Spaghetti is long. When you pile some on your plate, the strands get all intertwined. When a small child is given spaghetti, it is often chopped up into tiny pieces. That makes it easier to eat. That's because the long spaghetti resists the tension from your fork due to the tangles in the strands. Chopped up spaghetti has less tangles and less resistance. What does this have to do with the balls? Material objects are made of elements or molecules. Many familiar molecules, such as water, are made from just a few atoms. Rubber is a type of chemical called a polymer. A single molecule of rubber can be made of hundreds or even thousands of atoms. These atoms form long chains. Rubber is like spaghetti. In the happy ball, the rubber molecules are really long. This means that there are lots of tangles. When the ball gets deformed, those internal tensions pull the ball back to its original shape very quickly. The happy ball literally springs up off the ground. In the sad ball, the rubber molecules were cut shorter. There is much less tangling and therefore less tension and therefore less resistance to shape changes. When you drop a sad ball, it does not spring back up. You saw that the balls bounce very differently. Let's look at another experiment. Here I have a ramp set up with a wooden block standing up at the bottom of the ramp. I plan on rolling each ball down the ramp. Which ball, the happy ball or the sad ball, is more likely to knock the target block down? Remember, each ball has the same mass. Each one will go down the same ramp. That means their speeds will be the same at the bottom. If m and v are the same, that means each ball will have the same momentum when it hits the block. Let's observe what happens. The sad ball does not knock the block down. The happy ball does knock down the block. Is that what you thought would happen? Let's examine this in detail. We know that the momentum must be conserved in the collision. Our system is closed if we include just the ball and the block. In the case of the sad ball, the ball has momentum p before the collision, and the wood has none. After the collision, the ball stops. To conserve momentum, the block must have gained a momentum p. Okay? The case for the happy ball begins the same way. The ball has momentum p, the block has none. After the collision, the ball bounces backwards. His final momentum is negative p. In order to conserve momentum in the system, the block must gain a momentum of 2p. The happy ball gives the block twice as much momentum as the sad ball. That's why the happy ball knocks the block down. Let's switch to one of my favorite subjects, swords. This sword is a practice kendo sword. It's called a shinai. It is not wood. It's made from 4 slats of bamboo that are bound together with leather. The bamboo is thicker by the handle and thinner at the other end. There is a sliding band on the sword that lets you control how tight the bamboo bundle is. When the slide is up, the bamboo is loose, and the sword will act very much like the sad ball. Upon contact, the bamboo will squish a lot, but will not return quickly to its original shape. It makes a lot of noise as the bamboo clacks together, but you can pretty much hit someone as hard as you want, and it won't really hurt. However, if you pull the slide down and tighten up the bamboo, the sword will be very much like the happy ball. The sword will bend on contact, but it will very quickly return to its original shape. Just like how the happy ball could knock over the block, the shinai with its slide down can easily break someone's arm. Here's a different sword. This is a fencing foil. It is made of a tapered steel. The thick part near the handle is called the fort, which means strong in French. This part of the sword is used for defense. The business end of the sword is called the foible, which means flexible. This part is used for offense. Does this structure make sense to you? The defensive part of the sword is like the happy ball. An opponent's incoming swing that contacts with the fort will bounce off. Since you don't actually want to hurt anyone when we fence for sport, the offensive part of the sword is constructed like the sad ball. The sword bends, but the target remains unharmed.